Okay, I think we're going to get started. Thank you everyone for coming to the Princeton AI Alignment Speaker Series, today featuring Jerry Wei. Before we begin, we have QR codes that leads to princetonalignment.org around the room, so just before you leave, scan the QR code. If you want to learn more about safety and alignment in AI, then we have a lot of resources for this. So today, we have a very special talk for you. Jerry is an AI researcher based in San Francisco. He's been at Anthropic for the past 9 months working on AI safeguards. And before that, he was at Google DeepMind. He was a research engineer at Google DeepMind working on reasoning and factuality. So today he's going to give a talk on Anthropic's new paper, Constitutional Classifiers. And yeah, without further ado, please join me in giving a warm round of applause for Jerry Wei.
Testing. Thanks, Windsor. Today I'm going to be talking about constitutional classifiers. This is kind of an approach that at Anthropic we made to prevent models from being misused for purposes that we thought would cause catastrophic harm. So quickly about me, I studied at Stanford. I was studying CS, and I specialized in AI. And before that, or after that, I went to Google Brain. I was a student researcher working on reasoning for about 6 months. And then I joined Google DeepMind full-time as a research engineer. There I worked a little bit on sycophancy, worked on factuality and hallucinations. And then for the past 9 months, I've been at Anthropic. Originally I joined on alignment science, and then we now became the safeguards research team. So today I'm going to be talking about Anthropic's approach to AI safety and more general kind of like guidelines about how we think about AI safety. I'll then kind of talk about the constitutional classifiers framework, the method, how we developed it, how it works. We'll talk about how we evaluated it, how well it performs, and then I'll just end a little bit on broader implications of the work and how it might contribute to AI safety in the long term. So first, I want to talk a little bit about how we think about AI safety. So as AI systems become more capable, there are definitely going to be a lot of benefits to them. But at the same time, there's going to be risks. And although we already train language models to be helpful, and we train them to refuse harmful requests, it's still possible to misuse them in ways that we can't always defend against. And so the idea here is that we want to find safeguards that can balance between capabilities and safety. So at Anthropic, we created this thing called the responsible scaling policy. And this is basically a guideline that says, as our capabilities grow, we need to implement safeguards that allows us to be sure that we can deploy the models in a way that's safe, and we think in a way that mitigates substantial risks of deploying models. Specifically, there's these capability thresholds, where once we hit those thresholds, we think that there are new risks that are introduced if you release that model. And so that requires having new safeguards. And so the pipeline that we would typically go through here is first we would train some model. This could be a frontier model like Claude 3.7 Sonnet. And then once we have that model, we assess how capable it is. And if we find that it's capable enough to have new thresholds and therefore meet these new threshold requirements, we would determine that we need to have some additional safeguards in order to think that the model can be safely released. And so if necessary, we'll add some safeguards and we'll do some research on how we can have safeguards that reduce the risk of deploying a model to an acceptable level. And so the way I like to think about capabilities and the thresholds is that there's these levels of capabilities, right? And so at ASL 1, and ASL again is the AI safety level. At ASL 1, this is like no risk at all. This would just be like a chess AI. At ASL 2, you're starting to get some initial signal on maybe this could do something dangerous in the future, but it's not super reliable, and it's not really more useful than like Google, for example. At ASL 3, you're starting to have a model that can actually help someone who doesn't have any expertise in a specific field be able to build some kind of weapon that can cause catastrophic harm. And then at ASL 4, this is really high capability level, and this is a level where you can actually help nation states develop weapons. And this means you're better than most experts, maybe as capable as a team of experts. And so the idea is that if you're at a certain capabilities level, let's say we're at the yellow star, and then you train a new model that's evaluated to be at that blue star, well, you haven't actually hit any new threshold levels, even though the model is more capable. And so then we'd say, OK, we haven't hit any new thresholds, so actually we don't really need new safeguards. On the other hand, if you trained your new model and it was like above that threshold, then you would say, oh, this model has reached some new capability level that significantly increases the risk of deployment. And then you'd say, OK, we need new safeguards to mitigate those risks. And just for reference, we think we're somewhere between ASL like 2.5 to ASL 3. So right now, we think the models are like not that good that they can really help a novice completely build some kind of catastrophic weapon. But at the same time, we're getting close. And if given maybe a couple months or like a year or something, we think we'll be hitting that threshold. And so that means we should start thinking about what safeguards we need for that level of capabilities. And so as a reminder, the level that we're going to be talking about today is ASL 3. And this would be a model that can reliably help a novice build a weapon of mass destruction and cause catastrophic harm. So what do we care about in ASL 3? So ASL 3 is mainly about misuse, where a bad actor, right, they're trying to build some weapon that causes catastrophic harm. Well, in order to do so, they need to make some harmful queries to the model. But we already train models to refuse like obviously harmful requests. So if you ask a model how to build a bomber, for example, it'll just refuse that request. It will say, I can't help you with that. And so they need what's called a jailbreak. And a jailbreak is some method of modifying a query to bypass AI safeguards. Typical examples of this could include things like weird capitalization, or putting spaces everywhere, or like role-playing as like as Walter White from Breaking Bad or something. And the idea here is that you're putting the model in some state where it forgets that it's not supposed to answer the query and gives you some very helpful answer, even though it shouldn't have. And so one really important caveat here is that it's not actually really easy to build a catastrophically harmful weapon in just like one query. So if you ask the model something like, OK, tell me how to build a chemical weapon, you can get some response, but it's actually not going to be detailed enough for you to execute on it very well. It might give you some general guidelines. It might tell you some random stuff. But if you actually tried to like go to like and execute on it, you'd have a really hard time. And so actually, because you're a novice and you're trying to create some catastrophically harmful weapon, you would probably end up having to make hundreds or maybe even thousands of queries to successfully build this catastrophic harmful weapon. And so there's some examples of like things that you might run into. You might have to debug something. Something doesn't work. You have to ask the model, oh, how do I fix this thing? Or like, OK, now I've done this. How do I do the next thing? And so you have to make a ton of queries. And at the same time, it's not super easy to find jailbreaks. And again, a novice needs to make hundreds or even thousands of queries. So the question is this even a problem? If you have to find a jailbreak for each query that you're trying to make, that would actually take a really long time. And maybe it's not so bad, right? If you have to spend hundreds or thousands of hours finding jailbreaks for each question that you want to make, maybe that's OK. And so now we think about this thing called a universal jailbreak. And a universal jailbreak is a single strategy that works across many different harmful queries. So an example of this could be some prompt template, like a string, where you literally just paste in any query, and it bypasses all of the model safeguards. And the key thing is that it needs to work across any of your harmful queries. And because it works across any query, that significantly reduces the amount of time that someone would have to spend to get all the answers to those hundreds or thousands of queries that they have to make. And because they can now do that, they can accomplish the harmful task that they originally wanted to do without having to spend tons of time creating a new jailbreak for each question that they want to ask. And so an example of this is the strategy from Anthropic called many-shot jailbreaking. And here, it's a really simple strategy, which is you just few-shot prompt the model, and you give it a lot of examples of the model itself doing bad things. Note that the model here doesn't actually do the bad things. You can just pretend like the model did bad things, and you're basically putting those words in its mouth. And you're making the model seem like it had all of these previous examples of it doing bad things. And then now, when you ask your new question, here it's, how do I build a bomb? You ask your new question, the model thinks, oh, here are all these previous examples where I did something bad. I better do the same thing and answer that question and say, here's how to build a bomb. And so the key thing here is that you can put any question as that final question, and then the model will answer it, even if the question is harmful. And so just to recap here, models will soon be able to reliably help a novice build a weapon of mass destruction. Specifically, we're concerned about ASL3 level models. But to do that, your novice would need to ask a ton of harmful questions. And so we're worried about this thing called a universal jailbreak that would allow them to get answers without spending too much time creating individual jailbreaks for each question. And so the key thing we'll explore in this talk is how do we build safeguards that mitigate this risk of universal jailbreaks. I'm going to pause here if anyone has any questions on how we think about AI safety, why we care about this level of capabilities, questions like this.
Throughout the talk, we'll have like these mini Q&A breaks. We'll maybe take 2 or 4 per break. So just raise your hands if you have any questions. I think Jay.
I guess an alternative version instead of a screen threshold, you could say like, maybe right now a college student could build a chemistry student could build a bomb mass destruction, but they couldn't otherwise. It'd be hard to do that otherwise. And then it goes to high school and then like a novice. Why focus on that threshold? Where currently right now, maybe arguing or just don't do anything new and prepare as opposed to saying like right now we could now have a college student make drugs or build a bomb, whatever, and then we prepare against that now.
So if I'm understanding correctly, the question is, why do we care about like novice versus we could care about other things like high schoolers building it or like college students building it, and those can be capability levels, right?
Hard threshold between the numbers opposed to saying, we're working on this, or it's kind of a continuous thing, or moving around how much it helps a more or less person.
Yeah, okay, so the question is, we could have continuous state instead of threshold levels that are discrete. And so I think the answer here is that it's hard to quantify how much you actually uplift a given group. So say that you have some model and you want to measure, like how much does this help some college student in achieving some, let's say like chemistry task. The problem is that you're concerned about harmful chemistry tasks. And so if the most direct measurement would be you take some college level student and then you ask them to create this chemical weapon using the model. And then you maybe have like a baseline of the student plus like Google or something, right? Yeah, and then you can do this, and then like there are a couple of issues here. One is that it's hard to quantify how much they were exactly helped versus other factors like how good were they at prompting the model, did they ask the right questions, stuff like that. And then secondly, we can't really do the right thing that we want to do in practice because there's kind of this hazard of letting people build weapons, which is like, that's the whole thing we're concerned about. We don't want people to be able to build these catastrophically harmful weapons. But to measure it in that way, you would be trying to measure if they could do it. And so I think the best alternative that we've come up with is to set these thresholds where we evaluate the model, and these are all just like evals that we do internally, and they're just normal like capability level evals. And that means we don't have to do any like real uplift trials with actual students or like actual groups, and that helps us mitigate that risk.
How is the instance or the new thing of other people being able to make their own model based off of a model, like the way that DeepSeek trained its model off of ChatGPT? How does that raise some concerns about someone taking inputs from a Cloud Summit and making a model that doesn't have these safety measures?
Yeah, so the question is how do you prevent people from using your model to create an equally capable model that doesn't have the safeguards? I think, in particular, we are concerned about specific domains. So an example could be, if you're concerned about chemistry, then the question would be okay, how can you make sure that a competitor doesn't train an equally capable model at chemistry that could then be used without safeguards? And the idea is that if you can develop some safeguards that prevent your model from showing that harmful information in the first place, then it would be impossible to gather enough data at scale to train a new model. And so like, you need that initial data to distill to your new model. And so if you can prevent the actor from getting that data to distill to their new model, then even though they might get the normal information for like harmless chemistry questions or like other domains like math or coding, the model wouldn't have ever saw that like harmful chemistry information, and so it wouldn't actually know the answers for those questions for whatever the pipeline is for building a chemical weapon. And so by limiting what your model outputs in the first place, you can prevent what people can distill from your model. I'm going to move on here for the interest of time. I'm happy to chat afterwards if people have more questions. So now I want to talk a little bit about the constitutional classifiers approach. And that mainly there are a couple of criteria for safeguards. First of all, you want the safeguards to be robust. This is what we were talking about earlier, which is we want to defend against universal jailbreaks. It would be nice to defend against these individual jailbreaks too, but we care about that maybe to a lesser extent because, again, you have to make hundreds or thousands of queries to accomplish some goal. Secondly, an important thing that we care about is that whatever safeguards you develop, they have to be practically deployable. So this kind of differs a little bit from a lot of research projects, which is just like, let's just maximize robustness. Here, we're saying we want some safeguard that is still deployable in practice. And so things here could be, you don't want it to be too expensive, you don't want it to cost much compute, you can't let it refuse every query. I mean, on one end of the spectrum, you have like a rock, it refuses every query, completely safe, but not helpful at all. And at the same time, you need to care about user experience, so it can't be super slow. You have to be able to stream the outputs to the users. You have to be able to take in images, stuff like this. And finally, you want your framework to be flexible, right? Because your model may have new capabilities, and it might hit those capabilities at different times. So your safeguards need to adapt to different domains of harm. So for example, maybe your model first becomes really good at building chemical weapons. So you train your classifier to prevent information about chemical weapons. And then after that, your model then becomes really good at bioweapons. And then you need to adapt your classifiers. So they need to be adaptable. And then finally, they also need to be adaptable to new jailbreaks. So not every defense that you make can be perfect. And so over time, people will find new attacks to get past your defenses. And so you need to make sure that you create defenses in a way that you can quickly adapt to those new attacks and prevent them as soon as possible. So the approach we're taking here is a very simple approach, which is we'll just train some classifiers to look at user inputs and model outputs. And remember that the language model that we're actually trying to guard, it's already trained to refuse harmful requests, like obviously harmful requests. But because jailbreaks can bypass that, these classifiers function as an additional layer of defense, rather than the only layer of defense. And the way we typically think about it at Anthropic is this Swiss cheese model of defense, which is you have multiple layers of defenses. Each one might not be perfect, but if you have enough of these layers, it's really hard to get through all of them. So in our analogy here, the first layer would be your input classifier looks at the user input, and it determines whether that input might yield some dangerous information. And then secondly, the model itself can refuse to answer the request, right? It can say, oh, I don't want to help you with that. And then finally, if it does help you with that, the output classifier can then look at the output and say, oh, does this look like this is like dangerous information? And then if it is, we can block that as well. And so because we have all these layers, it's really hard to get past all three of them. So first for input classifiers, we have the classifier look at the entire conversation from the user. And that includes all of the previous user assistant turns. And the input classifiers serve as a first line of defense against jailbreak attempts. And this is really important because a lot of jailbreak attempts look really obviously like jailbreaks. And it's kind of like a product of having to trick the language model in some way. Because by tricking the language model, you need some way to make your query look odd or look different. And so the input classifier can help detect these kinds of texts. The example we gave earlier of many-shot jailbreaking, where you provide a lot of examples of the model doing bad stuff, that can be something that the input classifier looks at and says, oh, this looks very suspicious. Looks like the model is doing something bad. Let's block this. And the pipeline here is you start with user input, and then we apply a prompt wrapper around it, right? So here we just paste in the user input there in the placeholder, and then we essentially ask the model, is this conversation harmful? We give some criteria, and then the model predicts whether it's harmful or not. And then we train the classifier to basically do the next token prediction of, is this conversation harmful, yes or no? And then we can use that next token prediction as the classifier's probability of harmfulness. For output classifiers, we basically just look at model outputs while they're generated. This is an important thing that we have to allow the outputs to be streamed. This is mostly to preserve user experience. And importantly, because you've looked at it while it's streaming, you can block the output as soon as you detect any harmful content. And so if you see something that seems to be harmful, the user won't be able to see all of the other stuff that would have come after it. And another important detail here is that this output classifier doesn't see the user input. And so it's really hard for the user to apply tricks directly to this classifier. And again, the pipeline here is you start with model output. You just train a classifier to predict any score between 0 and 1 for each token. You have to do it for each token because you're preserving the streaming. And then you use that to predict the probability of harmfulness at each token. An example here is, let's say we have this model response. We're treating each word kind of here as a token, just as an example. And then you'll see at each position, we have some probability of harmfulness. And then you can see, this would be, for example, for some chemistry-related classifier. You can see the probability gets high for some detailed stuff like 5 or like phosphate buffered. And then if the confidence gets high enough, we can block the output, and then we wouldn't show anything after it was blocked. And the problem is, to train classifiers, we need data. So we need some pipeline that would let us build synthetic data to train classifiers. And so we use what's called a constitution, which is a natural language description of what's allowed and what's disallowed. So as an example here, this is again for chemistry. Harmful stuff could be like, acquiring restricted chemicals, purifying them, scaling up their production. Those are all bad things. But at the same time, we want to specify a bunch of harmless things because we don't want to affect the user experience. And the important thing here is because you're using a constitution, you can quickly adapt to new threats by simply rewriting the constitution. And because you separately had harmful and harmless categories, you can specify what the boundary is for the model to determine whether something is harmful or not. And another side benefit is that because it's written out in natural language, it's really easy to just look at the constitution and say, what is the model trying to do? What's it supposed to classify? So here's kind of the setup that we have here. And so given this natural language constitution, it has a few harmful categories, has a few harmless categories. We have a pipeline that uses that to generate a bunch of queries per harmful/harmless category. And so if your harmful category is something like how to build a bomb, that's bad, so let's block everything there. This pipeline would generate a bunch of user requests within that category. So it could be something like, how do I obtain materials for a bomb? How do I put them together? How do I do this while avoiding law enforcement or something? And so that's how you go from one single category to many sub-questions in that category. Then once you have the questions, you can simply use what's called a helpful-only model. This is a model that's trained without any safeguards. So it'll just answer any question that you give it. And then use that to generate model outputs for each synthetically generated input. Next, we are concerned about jailbreaks. So we need to apply some kind of augmentation to the data to make it seem like jailbreak-style data. And so there's a lot of publicly available jailbreak methods that are known. We simply implement them in Python as algorithms, and then we apply them to data, right? So if you have some kind of jailbreak that's like random capitalization, you can just make that as some algorithm and then apply it on your data to end up with some jailbreak-looking data. We also add some fixed set of harmless data. This is intended to mimic typical user traffic, again, in an effort to reduce the impact of these classifiers on your standard user who isn't asking about dangerous stuff. And you'll see that this is all in an attempt to address the criteria of being flexible. Because the constitution is so flexible, we can easily adapt to new domains of harm. Because the data augmentations are all synthetic, if we have a new jailbreak that comes in, we can just generate it in Python and then create new synthetic data with that. Okay, I'm going to stop here again if there's any questions about how this pipeline works, why we made it synthetic, stuff like that. I'll just call. Yeah, go ahead. Either one.
I guess my question was, how useful is the output classifier if once, let's say, you have a novel jailbreak, and you can get past the input classifier because you have an out-of-distribution jailbreak that you don't have any training examples for. If you are able to jailbreak, can't you easily obfuscate the output, like, I don't know, output letter by letter, for example?
Mm-hmm. Yeah, so the question is how useful is the output classifier if you already jailbreak the input classifier? For example, if you jailbreak the input classifier, you can then ask the model to output the answer in some obfuscated way, such that the output classifier doesn't understand it. And so there's two things here. One is that we do train the output classifier on seemingly out of distribution or jailbreak style data. So we do train on obfuscated style data. Secondly, for obfuscations in particular, we actually train our input classifier to block all attempts to obfuscate the output. And the reason we do this is because there is a gap between the capabilities level of the classifier and the capabilities level of the model that we're trying to guard. And the reason behind this is because the classifiers can't be as expensive as the model that you're trying to guard, mainly because it's really expensive to run, if that was the case. And so if there's a capabilities gap between your guarded model and your input classifier, then there exists some cipher or some encoding that the input classifier does not understand that the guarded model does understand. And so if that were the case, someone could discover this and then use that as a way to bypass the input classifier while still getting the answer from the guarded model. And of course, the output classifier also wouldn't understand this. And so to kind of get rid of that problem, for now, we've taken the extreme approach of just blocking all attempts to obfuscate it. And the intuition there is that it's easier to identify some weird-looking cipher than it is to actually decode the cipher. So hopefully that answered the question. I'll take one more question.
Thank you. I was wondering if there's been like any kind of research into like federated jailbreaking, where like maybe the queries are spread out across multiple users at different times. And so like one query on its own might not look harmful, but those collected could be.
Yeah, that's a really great question. So for distributed style jailbreaks or distributed attempts to acquire information, this requires a different approach. Classifiers are mainly deployed on per conversation or like per query style data, so you wouldn't, as you said, we wouldn't be able to see stuff like this. In fact, we do have some work on this, and the idea there is you need some monitoring algorithms to monitor user traffic. An example for this is that we have something called Clio, and Clio is a clustering algorithm that allows us to look at user traffic, and user traffic, of course, is very large, but allows us to basically group them into clusters and look at what people are using Claude for, and stuff like that. So if there was a distributed set of examples of someone asking about how to make chemical weapons, we would see that in the data. And so you were right that classifiers did not work for that, and so we are working on different stuff, different approaches for that. Cool, I'm gonna move on, and again, I'm happy to chat afterwards. I want to talk a little bit about how we evaluate our classifiers and how we make sure that they're actually good. There's two ways you can do this. One is the normal automated way. This is just like any other eval. You just have like some prompts and some outputs, and then you can just pass them in as strings to the model. The classifiers, you can see how many you block, see how many you don't block. They're really useful because they allow you to quickly iterate, and in AI, quick iteration is quite important. And you can also use them to calibrate your thresholds, which allows you to adjust how much you want to refuse, how much your over-refusal rate is, and therefore how much you impact normal users. And also, it allows you to test how well the classifier generalizes to out-of-distribution data. You can also do the more expensive human red teaming approach, where you hire actual jailbreakers to attack the system. Now, this is expensive, and it's quite slow to run, but this allows you to test robustness, this allows you to have the most similar setting to a real-world deployment of the model, because anyone can test it, and then they're trying to jailbreak it. This is a human trying to jailbreak it. One limitation there is that it only tests robustness, doesn't really test like over-refusal, stuff like that. So I want to first talk about how we do automated evaluations. First, we have some manually written forbidden queries. This is not that many. I think it's about 10. And then we apply some augmentations to mimic jailbreaks. Importantly, these include some held out augmentations, so some types of augmentations that the classifier never sees during training. And that helps us make sure that the classifier actually generalizes to other jailbreaking methods. And that lets you have some queries that look like jailbreak attacks. And then finally, we add a step where we remove attacks that are too complicated to answer. You can imagine, for example, that you have like some encoding that's applied on another encoding that's applied on another encoding, and so on. But at that point, you've applied so many encodings that even the model that you're trying to guard has no idea how to actually output anything. And so even though you didn't block it, you would never reveal anything actually harmful there. And then that becomes your final eval set. So as I said earlier, we can calibrate how much we affect users who aren't asking these harmful things. And the way we do that is we take normal chat conversations, Claude AI, wild chat, and then we can just basically measure how much our classifiers would refuse on those conversations at some given threshold. There's a limitation here, which is that you're assuming that all of these examples are like labeled as negative. I think this is a valid assumption for now because I think very few people are actually asking models how to make catastrophically or harmful weapons, but that could be different in the future. But yeah, we calibrate the thresholds on wild chat, and then we can test how well that generalizes by evaluating how much the over-refusal rate is on actual Claude.ai conversations. So there's this important question of what counts as a successful jailbreak. So as I said earlier, if you have some insanely complicated jailbreak, it might be so complicated that your model can't even answer it anymore. So first we have some output that we say, okay, it's gone past the classifiers. We need to see whether this is successful or not. First, we want to try to rewrite it in plain English. The reason here is that if you can't do that, then okay, you might have a problem here. And the way we do this is we just take the model, we take a help-only version, and then we ask the model to look at the input to try to get a key for how that output may have been obfuscated or encoded in some way, and then just ask it to rewrite in plain English. We then compare the output to a rubric. And the rubric is generated from a set of helpful-only model responses to the untransformed question. And the reason we do this is because there's some amount of information that you're trying to get from model with this query. And if you get the wrong information or you get different information, it's actually not that helpful to you. And so that's the reason why we need to compare it to a ground truth reference answer. And then that lets us determine the quality of the output, basically by prompting a language model to compare the two outputs, the target output and the predicted output, the jailbroken output, and then measure how much of those details overlap. So I want to first talk about our results on automated evaluations. First of all, for robustness, we compared to some prompted models, prompted classifiers as some baselines, and we saw that constitutional classifiers were, of course, the most robust. They successfully blocked 95% of jailbreak attempts, whereas the unguarded model only blocked 14%. So the increase in robustness there is quite significant. And then again, I keep reiterating this, but it's really important for us to try to minimize our effects on normal users. And so we care a lot about measuring how much we would be able to deploy some given system in public. And so we are finding that the refusal rate is increased by only 0.38%. This is not super large. Also, if you look at the error bars, it's kind of dubious whether it actually increased the refusal rate. The prompted baselines refused a little bit more, but it's not still not insanely large numbers. And another important thing is that your classifier should be cheap to serve. And we are finding that it added 23.7% of compute costs, which is like not negligible, but it's not like the end of the world to deploy that. The proper classifiers were basically doubling your cost of serving the model, and so that would probably be hard to deploy. And so the overall here is that they're more robust than prompted classifiers. They have less effect on production in terms of both overrefusals and compute costs. And just kind of like an aside here is that at all these AI labs, we care a lot about whether methods will scale well, because as models get better, you want to see whether your safeguards can also keep getting better. And so we looked at how the classifier performance would improve as you scale different things. So one is model size, your training set size, how much data you're looking at, and the number of kind of jailbreak augmentations that we applied. And generally, you can see that as you increase any of these, the performance goes up. And that's a good sign, because that means that in the future, as models become more capable, or as we're able to generate more data, we can expect that our classifiers will continue to get better. And so through these automated evals, we have seen that the method here is mostly practically deployable. There's reasonable compute cost. It's not like 0. But it's like reasonable to deploy. The overrefusals are minimal, so you don't affect normal users too much. At the same time, we've preserved streaming. The latency isn't too high, and stuff like that. I'm now going to move on to human red teaming. We had an initial version of human red teaming where we had 400 participants. Most of them had red teaming experience, so it wasn't just like random people. And we offered them up to $15,000 to basically do this task, which is given some number of queries, here it's 10, we want them to come up with some jailbreaking method that extracts the answers to each of those questions from the model that we're guarding. And so the pipeline here that they have is that first they come up with a jailbreak, then they need to apply that across all the questions they're given to try to extract answers. Then internally, we're going to look at those answers and see whether they're correct, whether they have enough detail, and whether they'd be like actionable in practice, basically. We also then give them some feedback, which they can use, again, to improve their attack. And also during the feedback stage, we would pay out if the jailbreak was successful. So we found that they spent about 3,000 to 7,000 hours. The estimation is a little bit rough here. And yeah, we were seeing that there wasn't a single jailbreaking method that could really get detailed answers for all of the forbidden questions. And another way to say that is that there wasn't a single universal jailbreak that worked for all the questions. Even the most successful red teamer was only able to get at most like 6 out of 10 questions answered using a single method. Just to get a little bit more signal here on which components of our approach are working, we looked at a random sample of queries from the red teaming program. And first, we found that standard harmlessness training is not that useful for them. And then secondly, we were finding that the classifiers that we tested significantly reduced the attack success rate. And that's the dark blue versus the light blue. And then afterwards, we did some separate efforts to further improve the system. And we found that our efforts there continued to improve classifiers, and the success rates there were even lower, which is the green versus the dark blue. Once we published our paper, we also trained a new set of classifiers based on our results from initial human red teaming. And here, we actually released these classifiers as a public demo for a week. We estimate that there were about 339 active red teamers. And again, we offered decently sized bounties. And yeah, given some queries, we tasked them with finding detailed answers for each query. One difference here is that we presented the queries sequentially as levels to a challenge, rather than presenting all the queries at once. And that means that the jailbreakers weren't forced to use the same strategy for every question. But at the same time, they were still incentivized to do universal jailbreaks because those had bigger bounties. So here we estimated that there were about 3,700 hours of red teaming effort. For the first 5 days of the demo, no one was able to pass all of the 8 levels. On day 6 and 7, 4 participants were able to pass all the levels. And one of them discovered what we thought was a universal jailbreak. 2 of them were non-universal, and then one more had a jailbreak that was borderline universal. And you can see here is the number of users that passed each challenge level. So yeah, the sense here is that we're seeing that it takes a lot of time to find a universal jailbreak if one can even be found. And so our conclusion is that classifiers are a way to defend against universal jailbreaks for a pretty large amount of time, at least with respect to an unguarded model. So to recap what we talked about here, at first, what we want to defend against is universal jailbreaks. And these are attacks that work across many different queries. We made constitutional classifiers, which is a practical, effective defense. And that allowed us to go from minutes to thousands of hours for someone to find a universal jailbreak. It also has minimal impact on legitimate use cases, which means it's deployable in practice. And it's a flexible framework that can adapt to new threats. I'm going to pause here again for any questions. Yeah. Oh, yeah.
So one of the, it seems like the output classifier is like, at least to me, it's like the backbone of this whole setup. So is there a way that, can you imagine like a way where the user instructs the model to output something like very long, like a long output, such that like the cumulative like prefix probability is like sort of out of distribution, or they might instruct the model to like say it in like Greek or some language that's not necessarily, I don't know if you guys would classify this as obfuscating it, but it's like out of distribution enough such that the model gets jailbroken. Is that something that Anthropic is concerned about?
Yeah, so the question is kind of about the generalizability of the output classifier. So to answer your question, we, first of all, do train on many different languages, not just English. And so I would imagine that the classifier is capable enough that it would understand most languages. Just for reference, the classifiers are trained from Claude 3.5 Haiku, which is a pretty good model. And so I think for most languages, it would be able to understand it. There are questions about whether it would generalize, but we believe we could just train on more languages or train on more data. And the other question is whether you can obfuscate it in some way, or
Like, if it was like a very long output and it wasn't immediately clear that, yeah, the probability is like super high.
yeah, so for long outputs, that's a good question. And so we actually had an experiment in our paper. I didn't include it in these slides, but we had an experiment where we tested whether the model, the output classifier, blocks the model's output early enough. And this includes on outputs that are extremely long. One thing to point out is that we do have a maximum output token length on our API, and so we didn't test on anything larger than that because it's not possible for users to get any outputs that are longer than that. But what we were finding was that the output classifier successfully blocked early enough that if you just look at the truncated response, it doesn't actually contain enough detail to constitute as a jailbreak. And so first of all, yeah, we do train on sequences up to the max token length from our models. So hopefully, long outputs aren't really that out of distribution because we train on them. And secondly, we were finding that even on these outputs, the output classifier first of all, did block and did block early enough in those cases. I think there's one more question here.
Yeah, I guess I have kind of a similar question.
Uh-huh.
Since you're training the classifiers on like a subset of like possible jailbreaks, do you have like any indication as to how well it would generalize to like some sort of like out of distribution jailbreak?
Yeah, the question is how well does our classifier generalize to out of distribution jailbreaks? So actually, if you look here, so yeah, the nice thing about our synthetic data is that we can actually classify whether a given jailbreak was held out or not during training. And so held out there is the blue line. And so yeah, you can see that the blue line is like also going up. So we expect that generalizability will increase as you scale up each of these things. And so even though it's like maybe like slightly lower than the brown line, which is like including the in-distribution ones, we expect that as you keep scaling up, it'll be good. I'm going to move on now to some broader implications of our work. So first of all, it's like, what is reasonable for AI security? I think it's really important to just accept that no system can be perfectly secure, and instead focus on making it as hard as possible for someone to get a successful jailbreak attack. And the idea is that if you make it sufficiently hard to succeed at jailbreaking the model, harder than what the perceived reward is, then people will essentially not be incentivized to jailbreak the model. The analogy I like to think of here is that imagine your like model is like a bike. It's like, right now it's like really easy to steal. So like maybe someone could just like take it and like leave. But if you put a lock on it, your lock's not perfect. I could get like, really big like pair of scissors or like a chainsaw or something, just cut through that. But it's kind of annoying for me to like go get that and like bring it over. And all I'm getting is your bike, so maybe I don't care that much. And so yeah, the idea here is that the classifiers are the lock. They make it kind of hard to get the nice output, the nice harmful output from the model. And so that maybe like a lot of users who would have used the model to do something bad are like, oh, you know what, this is like really hard. I'm going to do something else, explore a different approach. And another question is, okay, so you've had this, this classifier method. How do you actually build a safety case from that? How do you use this to say that some model is okay to deploy? And this is going back to the earlier question of how do you see distributed attacks? And it's important to remember that just one method like this, constitutional classifiers, is not enough to fully guarantee safety for some deployment. You also need a bunch of other things like bug bounty programs, right? Bug bounty program could be, oh, someone finds a jailbreak, so you incentivize that they report it to you first instead of releasing it to the internet where any bad actor could use it. Again, as I said, you could have something like Clio where you look at user traffic and try to find ahead of time whether people have found jailbreaks before they release it to the public so that you can adapt your responses to them. And yeah, again, if someone finds a new jailbreak, you want to be able to quickly adapt your models, your classifiers, to be robust against them so that they don't have much time to use that jailbreak. And in AI safety, there's always this question of safety versus utility. And so if you're typically in research, it's often easy to forget about the fact that you want your models to like remain useful. You want them to like be usable to people. You want them to be capable. So it's really important to have some kind of like close collaboration between a research team and a product team. Otherwise, it's really easy for the research team to just like think about one thing and then forget or like not have the right context on how that thing or like what the requirements are for something to remain productionizable. And yeah, things we care about here, time to first token, output streaming, latency. These are things that could be really easy to forget for some researcher, but with close collaboration, this allows us to maintain the user experience while having robust models. And another analogy here is that here's a scale of safety versus usefulness. If you're the most safe thing that's like not useful at all, you have a rock. I'm not going to get anything about catastrophic weapons from this, but it's also like not useful at all. And then on the other end, you have an AGI, no safeguards at all, just does whatever it wants. You can ask it anything. It helps you with everything. It's not that safe, but extremely useful. And ideally, you want to be somewhere here where you have something that's pretty safe and also pretty useful. Maybe it's not the maximal usefulness, but you want to be like on the frontier somewhere where like you have a good Pareto between usefulness and safety. I think that's basically it. And so I will leave it to any questions about broader implications. Actually, before I wrap up here, I will note that Anthropic is hiring. And so please reach out to me if you're on the job market. Software engineers, research scientists, I'm happy to connect. And I would love to learn about what people are interested in and what experience you guys have. And I can connect you with hiring managers as well. Yeah, thanks. I left my contact details there if anyone wants to grab that. But yeah, I'm going to leave it open to questions. Yeah.
It's kind of like a broader policy question, but going back to like safety versus utility, what are the broader mechanisms in Anthropic that choose like what is a harmful activity for the model to avoid beyond something like building a bomb or
Yeah, so choosing what things to avoid is largely dictated by our like threat modeling teams. One example of this team is we have something called the Frontier Red Team, and they look at they spend a lot of time thinking about domains and applications of Claude that could be dangerous. And importantly, they're doing this ahead of time. So they're trying to like predict or have some sense of like, oh, what would people use this for? What could they use it for? Could it be bad? And based on that, we can adjust like what we are using our classifiers for. Another example is that we could have something like Clio, where we monitor what people are using it for. We might see something that we missed. Maybe people are using it for domain X, and we didn't think of that before. So I think it's always important to keep an eye on what people are doing. Obviously, at some level, that's like mindful of the privacy, but at some distributed level, you can see what people use Claude for, and then you can adapt your defenses. Yeah. Yeah, so capabilities levels, there are many different ways you can evaluate it. One is you could look at typical evals like MMLU, GPQA. Specifically, if you're interested in this in domain, like for example, chemistry, you could look at the GPQA chemistry performance. I think there are also a lot of like niche data sets that we use that are open source, but like not used too much because they're like specifically measuring the model's performance in some like very niche chemistry like thingy that like no one else cares about. And I think a lot of those evals can give signal on how good your model is doing. Separately, you could do the thing of like trying to run uplift trials where you have someone implement some kind of thing that's like not actually a catastrophic, like harmful thing, but like it's like adjacent to that. You have them try to do it in practice using the model compared to someone doing it with Google, see how much better they do. That's another thing you could do. Yeah, I'll go here and then here. Go here first.
Is there any point where Anthropic would break user confidentiality in terms of their data? Like if you saw that they repeatedly attempted to get restricted domain info, would you start tracking that user more, or is that never taken into consideration?
That sounds like something I probably shouldn't answer. I'd like to say that I think Anthropic would just operate legally, but at the same time, we want to prevent misuse, right? So I think we would just do whatever is legal. Yeah, probably not a question for me, unfortunately. Yeah, over here.
What do you think is the importance of having a uniform policy or government regulation for this? So let's say if Claude is having these safeguards, what's to say that a user won't just try a different platform? And it also costs more for y'all to run these classifiers.
Yeah, this is a really great question and one that always gets asked. So the question is how can you ensure that whatever you do, someone else can't just go to a different competing model and then just use that without safeguards? And this is a really hard question because number one is we don't know what can be done on the policy side. And because we can't really assume that policy will be implemented or that other companies would be forced to do anything, our approach is kind of doing something, applying safeguards that are reasonable and easy to have. And the idea here is if you have these safeguards and you show that they have minimal effect on users, they're extremely easy to implement, they don't cost too much, and you basically make it as obvious as possible that this is really easy to do, then there's pressure on competing labs to also use that same system. And so even though they're not forced to, because it's so easy, they're like, oh, we could just get a free PR win or whatever if we just implemented this classifier. And then people who use their systems can just point at Anthropic and be like, oh, Anthropic did it, and their models are also good, so you should do it. And the hope is that there's pressure mounting on those companies to also adopt the safeguards. And hopefully that allows us to, without policy or without forcing other companies to, help encourage them to have safe AI. Yeah.
I was wondering what observability is most common to Anthropic. So I imagine for resilience and just making sure there's server uptime, there's a lot of observability. Maybe with AI safety, there's also certain observability that you guys look into as well. I was wondering on those two fronts what you guys care most about, and if there's another category that you guys care about.
I think most of the monitoring stuff we do would be with respect to safety, and I guess I think our societal impacts team also does a lot of stuff on what people use Claude for. I think recently they have some work on which jobs are most affected by Claude. For example, it seems like coding might be most affected, and so we might do studies like that. And those are also really cool studies. I would recommend checking them out. Yeah?
Yeah. Okay. Let's say we have a situation where like there's a doctor doing a surgery or something,
Mhm.
and then the doctor needs some sort of second perspective on what decisions to take. I think the idea right now is that you don't like. Let's say the model doesn't want to give information that could lead to some sort of risk, some sort of violation of like maybe your ethical constitution. Maybe the model gives like a suggestion that is risky and you still think that the patient or something like that. I think the idea right now is that the models just don't respond. But is there what is the thought process right now in terms of like overcoming that limit between usability and like safety?
Yeah, so the question is, imagine that there's some use case where some expert actually needs the answer to some like question that could be perceived as harmful, and the default behavior is the model would just refuse because it doesn't know this about the user. So I think there's two ways you could approach this. One is you could try to adjust the boundary of what the model refuses, and the other is you could adjust the boundary of when the model refuses or when it allows, or like when it like bypasses that safeguard or something. So sorry, one way you could imagine the second approach is like you could have, this is a personal opinion by the way, but you could have like some kind of like trusted user program or like some kind of organization where if someone's, they like, you verify their identity, they're like, oh, this guy's a doctor, then you can then allow it, right?
But then people like this, like I mean, I could still hold the certification of like, oh, like I'm a trusted doctor. But then at that moment in time, I don't know, maybe my wife wants to divorce me or something. I'm particularly like upset that they kind of decide to use my authority. Like, well, how do you do that?
Yeah, so I think in that case, you would still want to apply monitoring to see what people are doing, right? And so, yeah, again, as I mentioned earlier, like you can't really do anything catastrophically harmful with like 1 or 2 queries. You'd probably be making like hundreds or thousands of queries. And so if we had a good way to like look at all these distributed attacks or like, see what people are asking, I think in that case where like someone is like a trusted person and then becomes bad for like a day and then starts trying to do something bad, as long as they like were actually trying to do something bad, they would have to like spend a lot of time, first of all, finding a jailbreak, or I guess in this case they're like a trust user, so they like don't have it. But then like they're asking like 100, 200 like harmful queries. Even though it doesn't get blocked immediately, it still shows up in our monitoring, let's say, and then we see like, oh, there's randomly, suspiciously in these past 2 days, there have been 200 new queries about building a chemical weapon. That seems bad. That's what's going on here. So I think we could still detect that. Yeah.
Is there any plan to make some of these safeguards like available via API so other companies can use them for their work?
So I think the approach we've taken is we published a lot of details about our classifiers, enough that we think another company should be able to implement it themselves. I think there are other considerations of like trying to like give more than that that I don't think I can say too much about. But like, yeah, I think in general we want other companies to adopt this, and so generally we want to make it as easy as possible for them. Cool. Thank you all.
Yeah, that concludes the talk. Thank you everyone for coming. If you haven't scanned the QR codes, please make sure you scan it on your way out. PrincetonAlignment.org if you want to learn more about Princeton. Yes, there's also an AI governance and policy fellowship track if you're interested more in the governance side of things. But yes, PrincetonAlignment.org. PrincetonAlignment.org. Thank you, everyone. Oh, also, Jerry's going to stick around for a few minutes if you want to ask him any questions.